Chillers are large air conditioners that produce chilled water and distribute it throughout a building or cooling network through pipes to an indoor system that cools the air. The main chiller technologies are either compression cycle chillers and absorption chillers. Chillers have to reject the heat they extract from the building, and they do it either to water or to air. Water-cooled chillers use a condenser and refrigerant to reject heat to the water, that is, get the water to absorb the heat that has been extracted from the building. The water is then pumped to a cooling tower and circulated using fins to expel the heat to the atmosphere, typically through evaporation. In certain cases, cooling towers can be replaced by ground heat exchangers, which can reduce the amount of water to be evaporated. Air-cooled chillers, however, have condensers in which the refrigerant rejects heat directly to the outside air using one or more fans to cool the heat exchange coils. These are typically less efficient than water-cooled chillers. Other systems include evaporative coolers. These do not require a compressor or a condenser. They work in hot and dry climates by evaporating water on cooling fins and ventilating it to the building by fans. Evaporating water absorbs a significant amount of heat, which is known as the latent heat of vaporization. This cools the air in the same way that perspiration or sweat enables humans and animals to cool themselves. Absorption chillers are devices that can be fueled by gas or other sources of heat, such as industrial excess heat or solar thermal energy, which replaces the electricity used by a mechanical compressor. Lastly, geothermal or groundwater cooling systems chill water in part or in full using heat exchange with natural sources such as the ground, groundwater, rivers, and the sea. In these systems, water or a refrigerant fluid circulates through loops in the ground or groundwater where they reject heat absorbed from the building. This can be done with the use of a heat pump or directly without a heat pump.